DePIN starts in the physical world. Sensors, gateways, compute nodes, and edge systems turn real activity into usable network data. In this section, we'll look at how hardware choices affect cost, reliability, verification, scalability, and long-term network economics. We've already built the foundation: markets, incentives, economics, and architecture. Now we'll shift from network design to the devices that deliver real-world service. In DePIN, hardware is where the network touches reality. A device is more than a sensor or router. It provides service capacity, performance evidence, and eligibility for rewards. Whether it delivers coverage, compute, storage, energy data, or environmental readings, the network has to trust what it measures. That makes hardware quality critical. Strong devices improve verification and reliability. Weak devices create bad data, support costs, and unfair rewards. Choosing DePIN hardware is a balancing act. The device must meet the service requirement, whether that means sensing accuracy, compute, storage, bandwidth, or radio range. It also has to make economic sense for participants, including purchase price, installation effort, lifespan, and replacement timing. From there, evaluate whether it can survive real deployments, diagnostics, maintenance, remote management, and durability. Finally, check market readiness, including certifications, supply availability, warranty, and vendor support. The key point is that DePIN hardware cannot be judged with one universal checklist. Each network rewards the capabilities that make its own service reliable. A wireless device needs strong coverage, clean signal, and dependable backhaul. A compute or storage node needs processing power, memory, durable disks, and throughput. Sensors need accuracy, calibration, and environmental resilience. Mobility and energy devices add location, safety, battery, and equipment integration. The right device is defined by the job it performs. Hardware economics go well beyond the purchase price. A cheap device may help adoption, but frequent failures can quickly erase those savings through support tickets, truck rolls, and replacements. More durable hardware may require more capital upfront, but it can protect uptime and extend the earning window. A realistic model includes shipping, installation, power, connectivity, maintenance, and end-of-life costs. ROI only works when device performance matches rewards, utilization, and real market demand. Measurement integrity starts before deployment. First, define how accurate each reading must be for the use case. Then choose sensors that can reliably meet that threshold. Calibration sets the baseline, but it is not a one-time task. Devices drift as conditions change, firmware updates, or components age. Ongoing validation helps flag suspicious readings, so operators can recalibrate or replace equipment before bad data affects rewards, proofs, analytics, or customer trust. Every DePIN device has an energy budget. Grid power provides stability, but it limits placement. Batteries, solar, and vehicle power support remote or mobile deployments, but they add trade-offs: more maintenance, higher costs, and greater downtime risk. The biggest drains are radio communication, compute, sensing, storage, and even standby behavior. Low power design, sleep modes, and realistic sampling rates help energy last longer, which directly affects uptime, connectivity, and operating economics. Connectivity is the bridge between physical infrastructure and the DePIN network. Devices may use Wi-Fi, Ethernet, cellular, LoRaWAN, Bluetooth, satellite, or mesh depending on range, bandwidth, power, and cost. Gateways can aggregate local traffic, filter or pre-process data, manage devices, and send secure updates or commands back down. The main trade-off is resilience versus complexity. Redundant links improve uptime, but they also increase operating cost and deployment overhead. A device is not deployment ready just because the technology works. It also has to be legal to sell, safe to install, and available in the regions the network plans to serve. Certifications such as FCC, CE, UL, RoHS, and telecom approvals can affect launch timelines. So can import rules, radio bans, lead times, and spare parts. Treat compliance and supply chain as launch risks, because either one can become the bottleneck that delays scale. Deployment is where design meets reality. Even a strong device can fail if it is mounted in the wrong place, exposed to weather, poorly calibrated, or connected through weak backhaul. Match the deployment model to the complexity. Self-service for simple installs, technician or partner support for field work, and enterprise management for scale. Then standardize the workflow. Assess the site, mount correctly, verify power and connectivity, register the device, test performance, and activate only when results meet the expected baseline. Deployment is not the finish line. A healthy DePIN network runs as an operations loop. Monitor devices, diagnose issues, act remotely when possible, dispatch technicians when necessary, then verify and report outcomes. Maintenance includes cleaning, recalibration, diagnostics, inspection, and replacement. Firmware updates must be secure because they can patch bugs, improve performance, add features, or even change proof logic. Strong field operations also define escalation paths, warranties, service expectations, and clear replacement procedures. Observability tells a DePIN network whether real-world service is actually being delivered. Devices report metrics such as uptime, latency, throughput, signal strength, temperature, power level, and error rates. Health checks turn those signals into diagnoses: offline, degraded, tampered with, or affected by the environment. The same data supports protocol teams, device owners, support teams, and reward systems, helping the network respond quickly and fairly. Hardware strategy sits on a spectrum between control and openness. Proprietary devices give the network predictable performance, but they can slow adoption and create lock-in. Certified devices loosen that control while preserving quality standards. BIOD enables faster participation, but makes verification and support harder. Open hardware can unlock broad innovation if the community maintains clear specifications, testing processes, and governance. The right model depends on what the network needs to optimize. The big takeaway is that DePIN hardware is not just equipment. It shapes ROI, reliability, service quality, and trust. Strong networks balance cost, capability, durability, connectivity, and certification, then maintain deployments continuously. Next, we'll examine proof mechanisms, how networks verify that real devices are delivering real valid service.